This is for Year 10 Methods Pathways. We're going to look at question number 6 from exercise 10.3. So this is the exercise to do with mutually exclusive events. Now the scenario is there's a ball numbered from 1 to 30, or 30 balls numbered from 1 to 30, and a ball's taken out of the bag. So we want to find the probability that the ball number, the number on the ball, is either a 2, multiple of 2, or multiple of 3. Now, if I have a bag of 1 to 30, we know that there's going to be overlap between the event getting a number of multiple of 2 and multiple of 3, because if I have a ball number, say, that has a number 6, or a ball number that has the number 18 or 12, we know that 12, 18 and 6 are multiples of 2 and 3, so there's going to be overlap. So these events are not mutually exclusive. Okay, so they're not going to be mutually exclusive. Now, if they're not mutually exclusive, then we know the formula is probability of A or B is given by the probability of A plus the probability of B minus the probability of any overlap. Okay, and B. So we're going to find how many balls have models of 2, how many balls have models of 3, and how many balls have multiples of 2 and 3. So we can subtract it. So I'm going to do 6A. Probability of multiple of 2 or multiple of 3. I'm not going to write the full letter. I'm just going to write M2, M3, just for convenience. Is the probability of multiple of 2 plus the probability of multiple of 3 minus any overlap, multiple of 2 and 3. Now the reason why we're subtracting the overlap is because if I add the multiple of 2 and add the multiple of 3, I've actually double counted the ones that are multiples of 2 and 3. So I've double counted 6. Because 6, for example, 6 would be in my models of 2, but also is in my models of 3, so you double count of that, so you have to subtract one of them. Or do you have to subtract one of those overcounts? So the probability of models of 2, if you draw a set of 30 numbers, numbers 1 to 30, you'll know that there would be 15 out of 30. For multiple of 3, so you have 6, you have 12, you have 18, you have 24, you have and then you have 30, so you have 5. You should have, no, you should have 10. So let's draw a number line quickly. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Doing a number line because I don't want to miss any counts. 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So models of 3 is 10 out of 30. And what is models of 2 and 3? It will be 6, 1, 12, 2, 18, 3, 24, 4, and 35. So 5 out of 30. So you should get a total of 15 plus 10, which is 25, minus 5 is 20 out of 30. Now we know 20 and 30 both go into 10, so it's 2/3 is your final probability. So summarizing here, we trying to find the numbers which are models of 2 and numbers of models of 3. Because they're not mutually exclusive, we subtract the numbers that are multiples of 2 and 3. For part B, we want the factors of 12 and factors of 30. So we're going to do a sort of like a factor tree, so we don't miss any factors. So factors of 12, factors of 12 and factors of 30. Factors of 12 are 12, 6, 4, 3, 2. 4, 3, 2. Have I missed any? I don't think I've missed any. Factors of 30 are 30 itself, 15, 10, 5, 3, 2. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 1's also a factor. Now, we need to see what overlaps we have. So we have 3 overlapping, 2 overlapping, 1 overlapping. So I'm going to add these together and subtract any overlaps. Okay, so the probability of factor of 12 or factor of 30 equals factors of 12 are 1, 2, 3, 4, 5, 6. So 6 numbers out of 30 plus factors of 30, 1, 2, 3, 4, 5, 6, 7. 7 out of 30. And that gives me 13 out of 30. Now, we're not done yet. That's not my final answer, because I need to subtract the overlap because I've overcounted. I've overcounted because I've overcounted 1, 2, and 3 twice, so I need to subtract 3 out of 30. So 6 plus 7 is 13. 13 minus 3 is 10 out of 30, which equals, and 10 and 30 both go into 10, so it goes into simplifies to 1/3. So these questions aren't necessarily easy because they're quite tedious, since we have 30 numbers to consider and we have to look at factors of 30. So part C, we want an odd number or a factor of 20. So probability of odd or factor of 20. Now, odd I already know is 15 out of 30. Just if you count the numbers, you'll get 15 out of 30. So I'm not going to show you why that's 15 out of 30. For factors of 20, so factors of 20, let's work this out. Factors of 20, 20, 10, 5, 4, 2, 1. Just checking whether I'm missing any. I think that's the factors of 20. So the only thing that I need to subtract are 5 and 1. The reason why is these are factors of 20 and odd at the same time. So the probability of factor of 20 is 1, 2, 3, 4, 5, 6. 6 out of 20. And I need to subtract 2 because there I have overlap of 2. That should be at 30. So 21 minus 2 is 19 out of 30. Okay. So this is basically the methodology in which you do questions where you have overlap. So you just got to find what the probability of each individual thing is, and then find like where the overlaps are, and you just subtract the number of overlaps from the question. Now I'm not going to do part D. I want you to work that out by yourself. So have a go at this, but I should have given you enough information for you to have a go at it.